Hi, my name is Peter Thomas, President and Senior Engineer with Resource Compliance. Thanks for watching this training on IIAR Standard 6, titled Standard for Inspection, Testing, and Maintenance of Closed-Circuit Ammonia Refrigeration Systems. It is worth our time to review the contents of this important document, since as a document, Standard 6 represents the most significant RAGAGEP publication since IIAR Standard 2 was updated in 2014. Before going any further, I must warn you that this document also introduces an acronym that you may not be familiar with. The words inspection, testing, and maintenance are often shortened to ITM, so you'll need to log that into your expanding acronym memory as it will inevitably gain popularity in our industry. We've often heard the axiom that patience is a virtue. For the ammonia refrigeration industry, our patience has finally been rewarded with the publication of Standard 6. By some estimations, this document has been in development for over 13 years. Personally, I'm even a bit embarrassed at the number of times that I've promised clients that it would be published in the coming months. Countless IIAR Standards Committee meeting debates are interwoven into the fabric of this final document, which replaces the often cited IIAR Bulletins 109 and 110. My task in this presentation is to provide you with an overview of Standard 6 that will be both informative and relevant as a stakeholder in the ammonia refrigeration industry. Have you ever heard of a B109 inspection? B109 is the common name used for IIAR's Bulletin 109 minimum safety criteria for safe ammonia refrigeration system that has been referenced for annual mechanical integrity inspections for more than 2 decades. I lay this as a backdrop because it is important to understand that the content of Standard 6 was not developed from scratch. Many good and important documents laid the foundation upon which Standard 6 was constructed. Most notably, IIAR 6 builds upon and improves the content from several of IIAR's bulletins, namely Bulletin 109, 110, and 116. Bulletin 109 was published in 1997 and gained popularity primarily because of the checklist it contained, which came to be affectionately known as B109s. The B109 checklists were long considered the gold standard for both performing and documenting annual mechanical integrity inspections of ammonia refrigeration systems. Similarly, IIAR Bulletin 110 contained many helpful resources regarding inspection and maintenance of ammonia refrigeration systems. While there is a lot that could be said about Bulletin 110, one of the more noteworthy sections of this document is displayed on this slide and requires that relief valves be replaced every 5 years unless an improved alternative method is developed. At the time that the bulletins were published, it was not known that these documents would be viewed as recognized and generally accepted good engineering practice, or RAGAGEP, and therefore enforceable by OSHA and EPA. As such, the bulletins did not use code language, words such as shall and must, and are peppered with vague or optional requirements using words such as can, should, and may. For example, IIAR Bulletin 110 Section 6.4.2 reads as follows. The system should be checked regularly for the presence of non-condensable gases, which should be purged as necessary from the receivers and/or condensers, preferably into a non-condensable gas remover or purger, but alternatively into water. I think you get the idea. Just in this short paragraph, optional phrases are used 7 times. As OSHA and EPA began to utilize IIAR bulletins as enforceable RAGAGEP, it became clear that the best way to address the shortcomings in the bulletins was to retire them altogether and replace them with standards written in code language. Years ago, IIAR cast a vision to become the premier standard writing organization for ammonia refrigeration. At the time, the organization had only published 2 standards, but set its sights on a suite of standards to address ammonia refrigeration from cradle to grave. In the past decade, IIAR has been successful in becoming a recognized standard writing organization. All major model codes now provide direct reference to IIAR standards. The term model code refers to building codes, fire codes, and mechanical codes that are enforced by local building departments when a new construction occurs. In California, the governing model codes are the California Mechanical Code, California Building Code, and California Fire Codes. To stress the importance of IIAR standards in these model codes, I propose to you that when you hear the term IIAR standard, it carries the same weight as Mechanical Code or Fire Code. Standard 6 is the most recent addition to IIAR's suite of standards and was published in the summer of 2019. As a document, Standard 6 is divided into 3 parts. Part 1 addresses general requirements for inspection, testing, and maintenance program, while Part 2 contains the prescriptive ITM tasks for various types of equipment. Both Part 1 and Part 2 are normative, meaning that these sections are mandatory. Therefore, you'll see words such as required, shall, must, and will in these chapters. Part 3 contains several appendices that are informative or supplemental. These appendices are not intended to be required, but rather informational. In Part 3, you'll find words such as should, may, could, and can. To allay any worry that you might already be out of compliance due to the requirements in this new standard, it is worth highlighting that Standard 6 is a voluntary standard until adopted by an owner or an authority having jurisdiction. Thankfully, the text of Section 4.1.3 is consistent with the approach that we've promoted regarding RAGAGEP changes in the past. Facilities need not change their mechanical integrity RAGAGEP simply because a new standard has been published. However, this standard is the most current reflection of our industry's consensus toward inspection, testing, and maintenance of ammonia refrigeration systems, so it will be important to monitor how government agencies such as OSHA and EPA elect to use this document in enforcement. Before diving into specific requirements of any standard, it is necessary to understand who the standard was written for. In other words, is it IIAR's intention that this standard apply to me? The purpose of Standard 6 is communicated in Section 1.1, which states that the document specifies minimum requirements for inspection, testing, and maintenance for closed-circuit ammonia refrigeration systems. The next paragraph succinctly describes the scope of the standard as record-keeping, inspection, testing, and maintenance of closed-circuit ammonia refrigeration systems and ancillary equipment. It is worth noting that the scope of the document is not dependent on the amount of ammonia in a system. In other words, Standard 6 does not distinguish between Program 2 and Program 3 like the CalARP and RMP regulations do. Who is responsible for implementing an ITM program at your facility? Section 4.1.1 speaks to that very question when it states that the owner or the owner's designated representative shall be responsible for overseeing and ensuring that inspection, testing, and maintenance be performed in accordance with the requirements of this standard. While the owner or the designated representative is responsible for ensuring that ITM tasks are performed in accordance with Standard 6, compliance with the standard is voluntary until either of the following occurs. 1. The authority having jurisdiction adopts a standard, or 2. The owner adopts a standard. Common authorities include building and fire code officials, OSHA, US EPA, and local enforcement agencies such as the CUPAs in California. There typically isn't an official announcement when an authority having jurisdiction begins applying a new standard for issuing citation. So our industry will likely learn how each agency plans to enforce Standard 6 in the coming months. We advise all facilities to be prepared to defend the basis for each mechanical integrity task and task frequency in your PSM program. As stated earlier, a facility need not change RAGAGEPs simply because a new standard has been published. But due to the importance of this particular standard, it would be prudent to perform a gap analysis of existing ITM tasks against what is contained in Standard 6 and adjust your MI program accordingly. One of the more noteworthy effects of Standard 6 being published is that Bulletin 109 has been officially retired. IIAR Standard 6 Appendix B includes improved checklists that aim to build upon the foundation of B109. B109 included 10 checklists, while Standard 6 has 12. Notably, new checklists have been developed for purgers and ammonia absorption systems. The ventilation checklist in B109 has been expanded to include other safety devices and renamed safety systems. Some content has been moved from the B109 General Safety Checklist and placed in Safety Systems, so it was fitting to rename the checklist General System. To demonstrate the similarities between B109 checklists and the new IIAR 6 Appendix B checklists, this slide displays the air cooling evaporator B109 checklist on the left against the Standard 6 checklist on the right. The red circled areas illustrate just how similar the first page of the checklists are to each other. The questions on the back page nearly match each other as well. Each red arrow on the left matches with a red arrow on the right, indicating the question from B109 was included in Appendix B. A noteworthy difference between B109 and Standard 6 Appendix B is that the new checklists contain additional content that was not included in B109. It is beyond the scope of this presentation to address each change in the checklist, but this slide highlights 5 new questions that have been included which inquire about leaks, pipe labeling, valve condition, valve exercising, and instrumentation. Section 5.1 of Standard 6 lays out the foundational requirements of an ITM program. Most obligations in this section build upon an existing mechanical integrity requirement in the PSM regulations. For example, Section 5.1 requires that the owner or owner's designated representative shall ensure an inspection, testing, and maintenance program is developed to reduce the probability of an ammonia release. This language carries much of the same intent as Title 8, Section 5189, J1A, which states that the employer shall establish and implement written procedures to maintain the ongoing integrity of process equipment and appurtenances. As it relates to documenting inspection and tests, however, IIAR 6 requirements extend beyond PSM, as illustrated in this table. PSM only has 3 prescriptive documentation requirements, while Standard 6 has 12. For those utilizing PSM Writer to document ITM tasks, there is no cause for alarm, as the requirements for IIAR 6 were incorporated into the software long before the document was published. The next several slides demonstrate how PSM Writer addresses each of the documentation requirements in Standard 6. The name of the inspector is inputted into the completed by field. The serial number is documented by clicking on the equipment section, then selecting the associated equipment. Specifications for each piece of equipment, including serial number, can be viewed by opening the equipment record. An ITM description can be documented by typing into the work description text editor. Findings requiring correction are documented in the recommendations section. When adding a new recommendation, a description of the deficiency and the recommended remedial actions can be inputted. The person responsible for correcting the recommendation can be added in the responsible person field. And the due date of the recommendation can be selected from the calendar dropdown. Once the recommendation has been resolved, the completed date field is used to indicate the actual date that the item was addressed. Each work order can have multiple checklist questions which can serve to document the results of the inspection or test. Each question receives a yes, no, or not applicable answer. And the checklist comments field can be used for including information such as activation set points. I trust the previous set of slides helps reassure you that your Standard 6 ITM documentation requirements are being met if you're using PSM Writer. Say you have a task to perform a compressor inspection annually. On year 1, you complete the task on July 1st, which results in the same task being due on July 1st of the next year. When the next year rolls around, other obligations have filled the calendar during that period. In order to prevent the task from becoming past due, you knock it out early on June 15th. If the same situation occurs in subsequent years, before long, the task that was originally due in July is being performed in the spring. Standard 6 remedies this problem in Table 5.2, which defines the calendar basis of recurring frequencies used in the document. As the table illustrates, an annual task may be completed at an interval between 9 and 15 months and still be compliant. A task required every 10 years can be completed any time after 9 years or before 11 years to comply with Standard 6. Chapters 6 through 15 are filled with ITM tables, which list required tasks and frequencies. The frequency abbreviations used in the tables are shown in this slide. For example, when you see the letter S in an ITM table, you must recognize that the task is required semi-annually or every 6 months. Here is the ITM task table for compressors, which is included in Chapter 6. The table is laid out with the ITM task description in the left column and frequency that the task must be performed in the adjacent columns to the right. There are 3 columns to the right of the task descriptions which are used to clarify the requirements for each of the major compressor types: screw, reciprocating, and rotary vane. To demonstrate how to read the table requirements, compressor high discharge pressure cutouts must be tested annually as indicated by the A in the highlighted cells on this slide. We certainly don't have time to review each ITM task in Standard 6, but to help you get a sense of the breadth of the requirements, the following slides will quickly display each of the ITM requirements for compressors in Table 6.1. The following items must be inspected daily: compressor runtime hours, suction pressure, discharge pressure, oil pressure, oil temperature, discharge temperature, oil filter differential pressure, compressor motor amperage, compressor alarms and shutdowns, oil levels, oil leaks, rotary vane compressor lubricator oil levels. The compressor should be inspected for unusual vibration. Weekly, the shaft seal drip rate should be observed. Annual inspections include inspection of foundation, mounting bolts, metal surfaces for pitting or surface damage, inspect coupling for wear, starter connections, operation of oil heater, operation of unloader, alignment of motor drive shaft. Annual tests must be performed on the following: low suction pressure cutout, high discharge pressure cutout, high discharge temperature cutout, low oil pressure cutout, high liquid level cutout. Maintenance tasks in Table 6.1 include add compressor oil, change oil filter, clean external oil pump, perform oil analysis, align external oil pump shaft, change oil, verify coupling bolts are tight, replace shaft seal, measure compressor motor drive shaft alignment, lubricate compressor and external oil pump electric motor, check motor leads and insulation, verify integrity of control power, check starter connection, calibrate pressure and temperature switches, check rotor for axial play, open recip compressors to check pistons, rings, and plate valves, inspect vanes on rotary vane compressors, check belt tension where applicable, check pulley connections, check for electrical hotspots, calibrate motor current transducer, and calibrate capacity and volume slide valve. This is the final ITM requirement in Table 6.1. I realize that seeing all this information so quickly can be a bit overwhelming, but I think it is important to give a sense of how the tables in chapters 6 through 15 are constructed. Keep in mind that the previous slides displayed the requirements for one table, but there are 17 total tables in Standard 6. Section 5.3 summarizes minimum requirements for ITM program record keeping. Most of the items listed parallel an existing process safety information requirement in the PSM regulations. This table compares the requirements of Standard 6 to PSM. As you can see, Standard 6 does not introduce many new record keeping requirements. If you have already prepared process safety information documentation, then the requirements in Standard 6 are likely already addressed. Examples of required Standard 6 record-keeping documents are displayed in the next several slides. Examples of flow diagrams include block flow diagrams and P&IDs. Operating limits are typically addressed in process safety information, but are also included in key documents such as manufacturer data reports. Similarly, PSI requires a description of safety systems to be prepared, which typically includes a functional description of the detection system and other safety controls associated with the refrigeration system. Standard 6 requires a relief valve list to be prepared, which is also required as part of the relief system design and design basis requirement in process safety information. A functional description of the ventilation system should include system specifications along with control strategies. Most equipment installation, operation, and maintenance manuals are readily available on the internet and can be downloaded and organized with other ITM record-keeping documents. Other record-keeping requirements include obtaining vessel and heat exchanger data reports, organizing equipment lists with specifications, maintaining an operational log of key system parameters, documenting ammonia purity records, and maintaining a log of oil added to and removed from the refrigeration system. How long does Standard 6 require you to keep ammonia refrigeration records? Table 5.3.7 lays out the minimum retention period for refrigeration system records. As this slide and the next illustrate, the retention duration is dependent on the type of record. For example, engineering design documentation must be kept for the life of the process, but ammonia delivery records only need to be maintained for the previous 5 years. This concludes my presentation on an overview of IIAR Standard 6. The meat and potatoes of this document are in chapters 6 through 15, which contain inspection, testing, and maintenance task tables for each category of equipment. We highly recommend that you purchase your own copy of the standard from IIAR's website. If you have questions, feel free to contact us at 559-591-8898 or visit our website at resourcecompliance.com.